Hello everyone, my name is Anitha. I am from Mlritm. Today I am discussing about discrete mathematics. The topic in the discrete mathematics is well-formed formula. First of all, what is meant by well-formed formula? So, a formula which contains a connectives, logical connectives. Those connectives are AND connective, OR connective, NOT connective, implication and by implication. By using these connectives, we can define the statement with the help of parentheses. So, if a formula is said to be well-formed formula, we have three rules. So, first of all, see the first rule of well-formed formula. A statement alone is a well-formed formula. For example, statement P is a formula, then statement P is also a well-formed formula. Here, see here, statement P, like statement P is a well-formed formula, I am treating. Next one, alone of statement P is also a well-formed formula. And the second condition is, if statement P is in well-formed formula, then its negation P is also a well-formed formula. If statement P is a well-formed formula, then negation P is also a well-formed formula. Statement P is said to be in the form of well-formed formula, then we say that negation P is also a well-formed formula. If next third condition is, we are using connectives. Connectives are AND connective, OR connective, NOT connective, implication and by implication. If P and Q are compound propositions and the compound proposition is a well-formed formula, then the connectives are also in a well-formed formula. See the example. If P and Q are in well-formed formulas, then P or Q, P and Q, P implies Q, P by implies Q are also a well-formed formula. By using these well-formed formulas, we can identify the three definitions: tautology, contradiction and contingency. Now see the definition of tautology statement. So first one, tautology. Tautology means a compound proposition which is always true for all the possible components of a statement. See here, a compound proposition which is true for all possible truth values of components. For example, statement P and Q are the two compound propositions. The possible combinations of P and Q have the truth values either true or false. The possible combination of true or false. This compound proposition gives every time is true for all the components, for all the possible combinations. Then that is tautology. Generally, tautology is denoted by the symbol T0. Generally, tautology is denoted by the symbol T0. Next one is contradiction. Contradiction means it is the opposite of tautology. Opposite of tautology. That means a compound proposition which is false. A compound proposition which is false for all possible truth values of its components. For all possible truth values of its components. Generally, contradiction is denoted with the symbol F0. F0. Next one, contingency. Contingency is nothing but it is a combination of true or false for all its components, possible truth values of its components. Then that is contingency. If a compound proposition is true for all its components of truth values, then that is tautology. If a component proposition is false for all possible components of truth values, that is contradiction. If it is a combination of true or false, then that is contingency. See the examples of tautology, contradiction and contingency. So first one, we have to identify, here we have three examples. We have to identify these three statements, which one is contradiction, which one is tautology, which one is contingency. We see one by one example and how to calculate, how to check whether it is a tautology, whether it is a contingency or whether it is a contradiction. See the example. First example is P implies Q implies R, P implies Q implies R implies to P implies Q implies to P implies R. So first check the given statement is in well-formed formula or not. Now check the condition. We have to apply implication on Q implies R. First statement is P implies Q implies R. So first we have to identify the braces. Here first statement is square in square bracket, so it is in well-formed formula. Next one, we have to find that P implies Q and P implies R. Again, we have to apply implication on these two statements. So, and again, this is a well-formed formula. And again, if first statement and I am assuming this is second statement, I am applying here both the statements on implication. So, that is well-formed formula. This is a well-formed formula. So, the given statement is in well-formed formula. Then, how to find it is tautology, contradiction or contingency. The number of variables in a statement is 3 variables. The 3 variables are P, Q, R. First identify the number of variables. Number of variables are P, Q, R. So, total possibilities, that means all possibilities of truth values we get is 8 possibilities. Total combinations we get here is 8 possibilities. For 8 possibilities, I am writing here P, Q, R. Here I am getting 8 possibilities of PQR. Total combinations. How can you get 8 possibilities? Means for every variable we have 2 options, either true or false. So total options is 2 and 2 power n. N is the number of variables involved in a statement. So number of variables are 3. The number of variables are PQR. PQR the 3. So 2 power 3 we get total number of possibilities are 8. 8 combinations or 8 components we get here. For 8 components, for first variable you get 2 possibilities. What are the 2 possibilities? Either true or false. So first write down the possibilities of truths, after that possibilities of false. So write down 4 times truths. Write down next one 4 times false for P. Next one Q also get 4 times truths, 4 times false. So for Q write like this 2 times truths, 2 times false, again 2 times truths, again 2 times false. For third variable R variable also we get 8 components. In the 8 components you have to write down alternate of true false. So first one is true, second one is false, first one is true, second one is false, again first one is true, second one is false, first one is true, second one is false. For writing of these in this format, there is no corrections, there is no mistakes in truth table. So first I have to find out Q implies R. This is the first statement I am taking. Q implies to R. Once again I remind that implication. When implication statement will be false. If first statement is true, second statement is false, then it gives false. Implication gives false. First check the column of Q and second column and third column. Second column is Q, third column is R. So first I am checking the conditions of true false condition. Q is true, R is false. So in the second condition Q is true, R is false, then Q implies R is false. And again false true, false false, true true, and the sixth condition it is true false is there. So it gives false. Remaining blindly put trues. No need to check another ones. Simply it is true. Why? Because implication first statement is true, second statement is false. Implication gives false. Next one is second one I am performing P implies to Q. P implies to Q. Now apply implication on first column and second column. First column and second column. Again implication statement, first statement is true, second statement is false, it gives false. So I am checking for true false condition. So first one is true true, second one is true true, third one is true false, here is false, and fourth one is true false, here is false, and false true false true false 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 false. So again simply I am writing remaining all are trues. Next one, I am taking third statement is P implies to R. P implies to R. Again apply implication on first column and third column. Why? Because P is a first column, P representing the values are in the first column and R representing in the third column. Again apply implication on first column and third column. Again I am checking the implication value true false. So first both the values are true, second value is, first one is true, second one is false, so it is false. Again true true, again true fourth condition, it is true false, again false true, false false, false true, false false. So remaining cases it is true. Remaining cases it is true, simply true. So going to statement, first I am applying implication on Q implies R, next one is P implies Q, next one is P implies R. Again we have again I am converting the statement into two forms, first form and second form. First one I am treating as P implies Q implies R. This is statement A, and P implies Q implies R is statement B. I am assuming that first one is P implies Q implies R, second one is P implies Q implies to R. Statement contains all the implication connectives. So no need to confuse, convert the statement into subparts. So I am converting the statement into subpart. First braces I am taking as A, and the second square brackets in between square bracket statement I am taking as B. So first I am performing A. A means P implies to Q implies to R. P implies to Q implies to R. So here I am applying implication on columns, first column and fourth column. Implication on first column and fourth column. Now here I am checking if the first column is true, fourth column is false, then it gives false. Remaining cases it is true. So first combination is true true, second combination is true false, so it gives false. Again third combination is true true, fourth combination is true true, next combination is false true, next one is false false, next one is false true, next one is false true. So remaining cases it is true. Again I am applying implication on P implies Q implies to P implies R. So P implies Q implies to P implies R. So P implies Q is fifth column and P implies R is sixth column. Again I am applying implication on fifth and sixth columns. So I am checking for fifth and sixth columns. Here P implies Q is true, P implies R is true, P implies Q is true, P implies R is false. Therefore P implies Q implies P implies R is false. Again false true, again false false, true true, true true, true true, true. So remaining cases simply put true. No need to check. Only we have to check if the first column is true and second column is false. Again now final statement I am applying here. So final statement I am treating as P implies Q implies R is A, P implies Q implies to P implies R is B. So here I am applying implication on A to B. A is nothing but A equal to, I am taking the A statement as P implies Q implies to R, and B is P implies Q implies to P implies R. So now I am applying implication on A implies to B. Again I am checking for implication on last two columns. So P implies Q implies R. This is A. This is A. P implies Q implies to R. This is B. So here I am applying this column, this one A and B. So again I am checking for A is true, B is false. So check here, A is true, B is true. So it is true. A is false, B is false, true. A is true, B is true, true. A is true, B is true, it is true. Again A true, B true is true. A true, B true is true. A is true, B is true, true. A is true, B is true, is true. Therefore, A implies B is true. A implies B is true. Therefore, the given statement is a tautology. Tautology. Now check the possible conditions. What is the definition? Once again, we remember that. Remind that tautology. So check all the possible component combinations, truth value combinations of PQR. Given statement is PQR. This is true. All the statements are true for all the possible combinations of PQR. Here we have different combinations. If PQ are true, it is true. If PQ P and Q is true and R is false, it is also true. For any truth value of PQR, it gives tautology. Tautology is nothing but it is always true, or last column of a truth table is always true. Then for the possibilities of all the components of a given statement. Therefore, it is a tautology. So next example is P and negation P and Q. So here we have two variables. For every variable, two possibilities are there. 2 power n that equal to 2 power 2. Total combinations are 4. Total combinations of PQ is, for first variable, total possibilities, you have to write 2 times true, again 2 times false. For second variable, alternate of true, false, true, false, true, false. And the next one is, I am identifying negation P. Truth values of negation P. What is negation? It is a not connective. Negation connective or not connective. If not connective means, if P is true, statement proposition P is true, negation P is false. So here first statement, first column, P is true, negation P will be false. Again P is true, negation P will be false. Again P is false, negation P will be true. Again P is false, negation P will be true. Next, I am applying connective. First connective is negation P and Q. Negation P and Q. And connective is nothing but conjunctive connective. When the conjunctive connective is false means if both the statements are true, it gives true. Or if any one statement is false, it gives false. We have to remember two things. For conjunction, if any one connective is false, then it is false. Or if both are true, true. Now, I am checking for conjunction operation on third column and second column. So, third column and second column. First operation false, second one is true. So, first statement is false, therefore, and connective is false. Next, both are false, it is false. Again, both are true, it is true. Again, it is true, false, it is false. If any one statement is false and conjunction connective will be false. Again, I am applying conjunction on P, on negation P and Q. Negation P and Q. Again, I am applying conjunction on first column and fourth column. First column and fourth column. So, for first operation it is true, second value is false, obviously it is false. Again it is true, it is false, so it gives false. Again false, true, false true gives false, 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 false gives false. Therefore, here we get all the possibilities of a P and Q. We get the components of all possibilities false. Therefore, P and negation P and Q is a contradiction. Contradiction. Contradiction means a compound proposition which is false for all the possibilities of truth values of PQ. So, PQ, if both are P and negation Q false, true false is gives false, false true is false, false false is false. Therefore, for all the components of P and Q, we get the false condition, then that is a contradiction. Or else we can say that the final column of a compound proposition is all false, it gives contradiction. Next one is third example. P by implies negation Q. P by implies negation Q. In this statement, we have only two variables. So, total number of possibilities are 2 power n, that equal to 2 power 2. So, we get total possibilities are 4. So, possibilities I am writing here PQ. First possibilities are true, true. Second possibilities are false, false. And for Q operation, one time true, one time false, again one time true, one time false. First I am finding the negation Q value. What is negation operation? Negation means not operation. If P is true, first statement is true, negation statement will give false. If statement is true, then negation statement will give false. If the statement is false, negation statement will give true. So, P is true, negation Q will be false. If P is false, negation Q will be true. Again, Q is true, negation Q will be false. Again, Q is false, negation Q will be true. Negation means opposite condition. Statement gives true value, then it gives false condition. Negation will give false condition. Again, I am applying P by implies to negation Q. By implication condition. What is by implication condition? When it is true, if by implication condition P by implies P, let P and Q are both the propositions P, Q, compound proposition gives P implies Q, P by implies gives when it is true means if P is true, Q is true, by implication gives true. If P is false, Q is false, then by implication give true. If both are equal to truth or both are equal to false, by implication gives true. Or if P is true, Q is false, again P is false, Q is true, it gives false condition. In the opposite condition, it gives false operation. So, here I am checking, I am applying implication on first column and third column. First column and third column. So, first see the operation of first value. First value I am checking here. P is true, negation Q is false. I am applying implication on these two statements. So, true, false gives false. Again, P is true, Q is true, negation Q is true. Both are true, it gives true. Next one, false, false. Both are false, it gives true. Again, false, true, it gives true. False. Both are true, it gives true. Both are false, it gives true. Or if any combination true or false, false or true, it gives false combination. So, this is a contingency. Therefore, P by implies negation Q is a contingency. What is meant by contingency? Contingency means all the possibilities of a compound proposition contains combination of true, false, then that is contingency. Or else you can check the last column of a compound proposition contains a combination of true and false, then this is called contingency. The combination of compound proposition contains true or false, that is contingency. Okay, that means you can check simply, you can check the last column of a compound proposition which gives all possibilities are truth, then that is tautology. If all the possibilities of a last column gives false, then that is contradiction. It is a combination of true, that is contingency. Okay, thank you.